Hello, this is Mr. Best. Welcome to Chapter 9, Homework Questions 56 through 63. Question 56. Consider the two similar solids at the right. Part A. Create a map plan and draw the front, right, and top views for the solid on the left. So we're looking at this one. We're going to look at the front view. There's only two, so I'm going to cut out on this one. I have 3 by 3. I'm going to cut this entire column out because we don't need it. And then on the front, it's you're going to go 2 high all the way across. So this right here would represent what we see in the front, just a 2 by 2 basically. And then as you look from the right here, you're going to see let's see, from the right you're going to go 1 high in the first 2, and then right here you can see it goes 2 high, so we're going to go up 2. So this would represent what you see from the right side. And then from the top, you're going to see that this kind of L-shaped piece right here. You're missing all the other pieces, so. Alright, so that looks like the map plan. And then on part B it says, what is the linear scale factor between the two solids? So now we're looking at the first solid here, and then how it grows to the next one. So you can see there's a length of 3, and now there's a length of 6. So it goes from 3 to 6. You can look at some other ones as well. This one goes from 2 on top to 4 on top. So you can see that it's growing by a linear scale factor of 2. C, find the surface area of each solid. What is the ratio of the surface area, and how is the ratio related to the linear scale factor? So the surface area for the one on the left, we can look here and just kind of look at the different ones. We have 1, 2, 3, 4. But then you see the same thing on the back side. So the surface area is equal to 4 times 2. Plus you got 1, 2, 3, 4. So once again, 4 on the right and 4 on the left. And then on top you see 1, 2, 3, 4. So once again, 4 on the top and 4 on the bottom. So it looks like the surface area, you have 8 plus 8 plus 8, which would be 24. So we have 24 units squared for the surface area. And then for the surface area, instead of finding the surface area of the next figure, you can use, well, it's actually, I guess, asking how is the ratio related. Well, we should know that the ratio is related from the surface area, that if r is equal to 2, then r squared, which is for your area, is 2 squared, which is 4. So the surface area should be, for this one, is equal to 4 times the original of 24, which would give you a surface area of 96 units squared. How is the ratio related to the linear scale factor? Well, that ratio, 96 divided by 24, is equal to 4, which we already said. So r squared is going to represent your ratio of the surface area. On part D, it says now find the volumes of each solid. So if we look at the volume, we can see 1, 2, 3, 4, 5, 6. So the volume is equal to 6 units cubed. And then once again, from what we have previously learned, r cubed is equal to 2 times 2 times 2, which is 8. That's how much the volume grows. So it's 8 times the original of 6, so therefore our volume is going to be 48 units cubed. And so that's going to be a ratio of 8, which, once again, is in terms of the volume, that's what it represents. So find the volumes of each solid, which we did. How are the volumes related? We already said that the volumes are related by the r cubed, which represents 8, and compare this to the linear scale factor. Once again, it is the cube of the linear scale factor. Question 57. Elliot has a modern fish tank that is in the shape of an oblique prism, shown at the right. A. If the slant of the prism makes 60-degree angle, what is with the flat surface on which the prism is placed, find the volume of the water the tank can hold, assuming that each base is rectangular. So we have our base, it's 13 by 7, so we need to figure out how many layers we have, so we got to figure out what the height right here is. This is a special right triangle, a 30, 60, 90. We know that this distance here is the same as this distance, so we know it's 12. So that's the hypotenuse, which means the short leg will be 6, and then the long leg will be the square root of 3 times the short leg, which would be 6 square roots of 3. So for part A, to find the volume, we want to take the area of the base, which is 13 times 7, and multiply that by the height, which is 6 square roots of 3. So the volume could be rewritten as 546 square roots of 3, or we can approximate that to 945.7 cubic inches. For part B, if Elliot has 25 fish, how crowded are the fish? That is, what is the density of the fish measured in number of fish per cubic inch? So there's 25 fish, and then per cubic inch we have the total cubic inches, 945.7 inches cubed, and this is the number of fish. So this will be equal to approximately 0.026, and this will be fish per cubic inch. Okay. Now that might be a little hard to realize in terms of just a cubic inch is not very big for a fish anyways. So in part C it says, what is the density of fish in Elliot's tank in fish per cubic foot? So, 1 foot by 1 foot by 1 foot. So we still have 25 fish. We still have it over 945.7 inches cubed, but we want to change it to feet. So there's 12 inches in 1 foot. But that's only going to cancel the inches one time. You got to cancel it every single time. So there's 3 of them. So you're going to have to do 3 of these. 12 inches over 1 foot. 12 inches over 1 foot. And so now you can see inches cubed cancels, 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 cancels. And that's going to leave you with fish per cubic foot. So that's equal to the numerator 43,200. Divided by the 945.7, and that's going to be approximately, so that'll be approximately 45.68 fish per cubic foot. And so I think that answers all those questions that we were trying to find out. Fish per cubic foot, we found the fish per cubic inch, and then we found the volume of the fish tank. Question 58. Decide if the following statements are true or false. If they are true, explain how you know. If they are false, provide a counter example. Question A. If a quadrilateral has 2 sides that are parallel and 2 sides that are congruent, then the quadrilateral must be a parallelogram. And this would be false, and the reason why is because you could have an isosceles trapezoid where these lines are parallel and then these would be congruent. So an isosceles trapezoid would be a counterexample. Part B. If the interior angles of a polygon add up to 360 degrees, then the polygon must be a quadrilateral. And that is true because the sum of the interior angles of a quadrilateral is equal to 360 degrees no matter what. So part C, if a quadrilateral has 3 right angles, then the quadrilateral must be a rectangle. That is also true. So 3 right, 1, 2, 3. So 1, 2, and then once you create that third one, it's going to create a rectangle. If the diagonals of a quadrilateral bisect each other, then the quadrilateral must be a rhombus. And that will be false. Whoops. Try that again. And for example, a parallelogram, if the diagonals of the quadrilateral bisect each other, then the quadrilateral must be a rhombus. So a parallel is an example of where that will happen, but it is not a rhombus. Question 59, write and solve an equation based on the geometric relationship shown at the right. So this length is equal to this one, and then on this other triangle, those two side lengths are congruent, which means this line segment right here is halfway in between those side lengths. So in terms of the ratio, if this is, x, then this whole thing would be 2x. So it's double what that triangle is on top. So therefore, then we should be able to say that 2 times 12x plus 7 is equal to 30x minus 4. And so when we distribute, subtract 24, add 4, and then divide by 6, x is equal to 3. Question 60, solve each equation below, check your solution. So on the first one here, we're going to go ahead and distribute the negative 6, and then we'll combine our like terms. 20 minus 30 minus 12x is equal to 10 minus 2x. 20 minus 30 is negative 10. Let's go ahead and add 2x to both sides. That's negative 10 minus 10x is equal to 10. Lots of 10s here. Add 10. Negative 10x is equal to 20. Divide by negative 10, and x is equal to negative 2. And it does say check your solutions on here. I'm not going to go through and check every single one of these, but what you would need to do to check your solution is to plug negative 2 back into the original equation. 20 minus 6 times 5 plus 2 times negative 2 is equal to 10 minus 2 times negative 2. So this would be 20 minus 6 times 5 plus negative 4 would be 1. And then this would be 10 plus 4. So 20 minus 6 is 14. 10 plus 4 is 14, so it checks. Let's go to B. B is 2x squared minus 9x minus 5. This is a quadratic, so you can solve this by factoring potentially or completing the square or the quadratic formula. I'm going to go ahead and try to factor this one. So we're going to use our generic rectangle. We have 2x squared and minus 5. And we're looking for things that multiply to give us negative 10x squared. That's these two numbers being multiplied together have to also equal the product of those two. So we're looking for something that multiplies to give us negative 10x, but then adds to give us negative 9x. So that would be negative 10x and 1x. So it multiplies to give us negative 10, adds to give us negative 9. We can then split those two up and then work backwards. So we know 2x squared is 2x times x. The 2x has to be on this side, so it goes into the 10. 2x times negative 5 is negative 10, and then x times 1 is 1x. So therefore we can factor this to 2x plus 1 times x minus 5, and that is equal to 0. Then we can apply our zero product property, saying that when two numbers are multiplied to give you 0, one of them must be 0. So we'll set both factors equal to 0 and solve. One of our answers is x equals negative 1/2, and the other one is x equals 5. So negative 1/2 comma 5 is the solution for that quadratic. Once again, to check, you plug those back in and see that they work. All right, we're going to move on to C. C, we have 3 over 5x minus 1 is equal to 1 over x plus 1. I'm going to cross multiply here. That will give me 5x minus 1 times 1, which is still 5x minus 1. And then 3 times x plus 1. All right, now I'm going to go ahead and distribute. That's 3x plus 3. Subtract 3x. Add 1. 2x is equal to 4. Divide by 2. X is equal to 2. And once again, you can plug that back into your original and see that it works. And then now let's move on to D. D is an absolute value. So the absolute value of 2x minus 1 is equal to 5. If I cover this up here, what two numbers could I replace that with? That would be 5 and negative 5. So we're going to say that. We're going to say we got two equations here. 2x minus 1 could equal negative 5, and 2x minus 1, minus 1 could equal a positive 5. And we'll just solve both equations. So add 1. 2x equals negative 4, so x would equal negative 2. Add 1 to positive 5, that would be 6. And then x would equal 3. So we have two solutions. X equals negative 2 comma 3. And once again, the curly brackets, since there's two solutions. So if you go back to the original four questions you're looking at, you have a linear equation on A. B is a quadratic. C, you're still looking for linear equations, but you have the denominator in terms of x, so we do have some restrictions along with that as well. And then D is your absolute value equation. Question 61. A new car purchased for $27,000 loses 15% of its value each year. What is the multiplier? So we're looking for the multiplier. So what do we need to multiply the 27,000 by? It's losing 15%. So we started 100% and we lose 15%. So that's going to put us at 85%. So the multiplier would be 0.85. Part B, write a function in the form f of t equals ab raised to the t power. That represents the situation. So t is your time, a is your initial, which would be the 27,000, and then b represents that multiplier. So our equation would be f of t equals 27,000 times 0.85 raised to the t power. At the current rate, what will be the value of the car in 5 years? So now we can plug 5 in for our time and calculate the value of the car in 5 years. So that'll be worth $11,980.04. So I'll write that as money. Oops. So this will be in 5 years. Question 62. Examine the information provided in each diagram below. Decide if each figure is possible or not. If the figure is not possible, explain why. So right now, let's figure out this angle right here and see if it matches up with the sum, and it should be supplementary to this, and then all three angles should also add up to 180. So we're going to take 180 degrees minus 120 degrees, and that will be 60 degrees. So right here, if this is 60 degrees, is 60 plus 64 plus 56, does that equal 180 degrees? And it does, so this one is possible. On B, we have 62 degrees and 117. Since those lines are parallel, these are same side interior, and same side interior should add up to 180. They should be supplementary. So is 62 degrees plus 117 degrees equal to 180 degrees? And that is not equal to 180 degrees, so it is not possible. Because the same side interior angles are not supplementary. Part C, we have 72 and 54 on this triangle. This one says 71 over here. These two are vertical angles, so they should be the same, and they're not going to be the same because we have 54, so these are congruent right here, but then 171 and 72, so those two values right there are not going to be equal, so therefore this one is not possible as well. And that's, because of the vertical angles are going to have different measures, and vertical angles have to be congruent. And so I marked the two angles that are not congruent, 54 and 55. So once again, not possible because the vertical angles are not equal. Question 63, multiple choice. For angle ABE, so ABE, it is congruent to angle BEF, so BEF, so this one and this one is congruent. In the diagram below, what must be true? And so if these two angles, these two lines, are cut by this transversal and your alternate interior angles are congruent, then it means that these lines should also be parallel. So does that say AC is parallel to DF? AC is parallel to DF. So that one is good. Let's look at some of these other ones here. It says AC is parallel to GH. That's not true because one's going this way and one's going this way, so that's not true. Let me get rid of some of that here. What about these angles up here? ABE is congruent to BED. Oops. BED. No, those aren't congruent because those are same side interior. They're supplementary, so that one is not true. That one's not true. And then what about angle ABE? So ABE again is congruent to GBC. GBC. Yes, those would be congruent because they would represent vertical angles. So it looks like B and D are your two choices.